A very good morning to one and all. This is Sasitra, Assistant Professor, Department of EEE, KSR College of Engineering. In this video, we will see the electromagnetic induction. What is electromagnetic induction? The electromagnetic induction means the electricity induced by the magnetic field. This is explained by Faraday's law of electromagnetic induction. There are two Faraday's law. The first law defines how a magnetic field EMF gets induced in the magnetic field, and the second law explains about the value of induced EMF, amount of induced EMF. The first law is whenever the magnetic lines of force linking with a coil or a conductor changes, an EMF gets induced in the coil or conductor. This is Faraday's first law. And the Faraday's second law is the magnitude of induced EMF is directly proportional to the rate of change of flux. This is Faraday's second law of electromagnetic induction. So, this induced EMF, there are two methods of inducing this EMF. One is statically induced EMF and another one is dynamically induced EMF. Statically induced EMF means static means there is no mechanical movements. If there is no mechanical movements to induce EMF, then it is called statically induced EMF. For example, the conductor which is placed in the magnetic field remains stationary and flux links with the conductor is changed. How this flux linkage is changed means by changing the current, which is the cause for producing flux linkages. We can change the flux linkages by increasing or decreasing the current passing through the coil. This is called statically induced EMF. And this statically induced EMF again further classified into two types: self-induced EMF and mutually induced EMF. So self-induced EMF means we have a coil. Look at the picture. We have only one coil. We are passing a current through this coil. Due to this current, there will be a setup of magnetic field. So this magnetic field flux lines links with the conductor. Whenever we are changing the current, there will be a change in flux linkages. Due to this change in flux linkages, an EMF will be induced in this field. So this is called self-induced EMF. So the EMF is induced in the conductor due to the current flowing in the same coil. This is called self-induced EMF. And coming to the mutually induced EMF, we have two coils, namely A and B. We are giving supply to the coil B. So due to this supply current, there will be a setup of magnetic field, and this magnetic field flux will link with the coil A also. So this flux linkages will induce EMF in the second coil. If we have any closed path, we can see the current flow through the closed path also. So this induced EMF is called mutually induced EMF. So in EMF induced in a coil due to the current flow in the neighboring coil is called mutually induced EMF. And second type is dynamically induced EMF. Dynamically induced EMF means the conductor parts is rotating in nature. So in statically induced EMF, we are not rotating the conductor, only the current passing through the circuit is changed to change the rate of change of flux. Here in dynamically induced EMF, the conductor is moved. The conductor is not kept stationary. So to create rate of change of flux, to create change in flux, the conductor is moved in a magnetic field. So due to the movement of conductor, the conductor cuts the flux lines in the magnetic field. This creates rate of change of flux. So due to this rate of change of flux, we have an induced EMF. This induced EMF is called dynamically induced EMF. So this is all about statically and dynamically induced EMF. Next video, we will see the a magnitude of statically induced EMF and magnitude of dynamically induced EMF. Thank you.